Good morning, Montfortians. Today we are going to start with our next topic, that is elevation in boiling point. Before starting with the topic, let us understand what is boiling point. For any liquid, boiling point is that temperature at which vapor pressure of liquid is equals to the atmospheric pressure, that is 1 atm. Vapor pressure of liquid is equals to the atmospheric pressure, that is 1 atm. Now let us understand our topic with the help of graph, where on the y-axis I have written vapor pressure and on the x-axis I have written temperature. And this is a point where vapor pressure is equals to 1 atm. Now, as you all know, when we will increase the temperature, vapor pressure will also increase, and then the point will come where vapor pressure of liquid or pure liquid will becomes equals to 1 atm, and that point I have represented with TB naught. TB naught is the boiling point for pure liquid. Now, if we will add in pure solvent non-volatile solute, then vapor pressure will decrease, because vapor pressure of pure substance is greater than vapor pressure of solution. If vapor pressure will decrease, then it will take more temperature to boil or to reach till 1 atm. Then a point will come where it will cut 1 atm. That point is known as its boiling point, that is boiling point of solution, that I have represented with TB. TB is the boiling point for solution. Now you can see, when we have added impurity in pure substance, then boiling point has been increased from TB naught to TB, and this gap shows the change in boiling point, that is elevation in boiling point, and which I have represented with delta TB. Now what is delta TB? Delta TB is change in temperature, that is TB minus TB naught, final minus initial. Now as you know, delta TB or elevation in boiling point is a colligative property, and colligative property is that property which depend upon the quantity of solute or concentration of solute. Then we can write delta TB is directly proportional to molality. Why molality? Because it is a concentration term, and here we have to take that concentration term which is temperature independent. Now if I will remove this proportionality sign, then what will come? Constant. So delta TB is equals to Kb into m, or molality. What is Kb? Kb is molar elevation constant of solvent, and m is molality. What is molality? Molality is number of moles of solute upon weight of solvent in kg. That we can write given mass upon molar mass into weight of solvent in kg. Now delta TB is equals to Kb into given mass upon molar mass into weight of solvent in kg. If I want to write this in grams, then delta TB is equals to Kb into given mass upon molar mass into weight of solvent in grams into 1000. This is elevation in boiling point. Now come to next colligative property, that is depression in freezing point. Before starting with the topic, let us see what is freezing point. Freezing point is that temperature of any substance at which vapor pressure of its liquid state is equal to vapor pressure of its solid state. Vapor pressure of its liquid state is equals to vapor pressure of its solid state. Now let us understand our topic with the help of graph, where on the y-axis I have written vapor pressure and on the x-axis I have written temperature. Now when we will decrease the temperature, vapor pressure will also decrease, and vapor pressure of solid will decrease more faster than the vapor pressure of liquid state. Now in liquid state, as we will decrease the temperature, vapor pressure will also decrease, and a point will come where it will cut the vapor pressure of solid, and that point is known as freezing point of pure liquid, that I have represented with TF naught. TF naught is the freezing point for pure liquid. Now when we will add pure solvent in non-volatile solute, then vapor pressure of solution will decrease, And if we will decrease the temperature, vapor pressure of solution will also decrease, and then a point will come where it will cut the vapor pressure of solid, and that point is known as freezing point of solution, which I have represented with TF. Now, you can see when we have added impurity in pure substance, then freezing point has been decreased from TF0 to TF. And this gap shows the change in freezing point, that is delta TF. So, delta TF is the depression in freezing point. Now, delta TF is equals to change in freezing point, that is TF0 minus TF, final minus initial. As you all know, delta TF or depression in freezing point is a colligative property. And what is colligative property? Colligative property is that property which depend upon the quantity of solute or the concentration of solute. So, delta TF is directly proportional to molality. After removing the sign of proportionality, what will come? Constant. So, delta TF is equals to Kf into m, where Kf is molar depression constant of solvent and m is molality. What is molality? Given mass upon molar mass into weight of solvent in kg. So, delta TF is equals to Kf into given mass upon molar mass into weight of solvent in kg. Now, if I want to calculate in gram, then delta TF is equals to Kf into given mass into 1000 upon molecular mass into weight of solvent in gram. This is the expression for depression in freezing point. Now, come to next topic, that is units of Kf and Kb. From these two expressions, you can see Kf and Kb is equals to delta T upon m. If delta T unit or the temperature unit is degree C, then molarity unit will be molar. And if the temperature unit is Kelvin, then molality unit will be mole per kg. Now, come to last colligative property, that is osmotic pressure, which we are representing with pi. To understand osmotic pressure, first we have to understand the concept of semi-permeable membrane. What is semi-permeable membrane? Semi-permeable membrane is that membrane which allows solvent particle to pass through it, because the size of solvent particle is very less. Now, to understand osmotic pressure, we have to take a beaker and keep semi-permeable membrane, which allows solvent particle to pass through it because they are small in size. Now, on this side take pure water and on other side take seawater, means it contains water plus NaCl. So, it is a solution. Now, on this side the concentration of water is high and on this side the concentration of water is low. So, now water will flow from high concentration to low concentration, and that is known as osmosis. What is osmosis? Osmosis is a process when solvent flow from high concentration to low concentration by the means of semi-permeable membrane. And after some time, the level of water on this side will decrease and the level of water on this side will increase. Now, we want to stop the flow of water from pure side to impure side because we want pure water. So, to stop this naturally occurring osmosis process, we have to apply pressure on this side. So, that pressure is known as osmotic pressure. What is osmotic pressure? Osmotic pressure is that applied pressure so that osmosis process stop, and it is represented by pi. Now, we want water should flow from low concentration to high concentration. Then for this we have to apply that pressure. We start the process of flow of water from low concentration to high concentration. That process is known as reverse osmosis. Reverse osmosis is that process in which when applied pressure is more than osmotic pressure, then solvent flow from low concentration to high concentration. Now, we want to calculate the value of osmotic pressure. For this, we will use ideal gas equation because we can compare diluted solution with ideal gas equation. So what is ideal gas equation? Ideal gas equation is PV is equals to nRT. In case of osmotic pressure, pressure is represented by pi. Pi V is equals to nRT. Now pi is equals to NV into RT. N upon V is molarity, number of moles upon volume of solution in liters. And molarity is a concentration term. Then in place of NV we can write C, that is concentration. So pi is equals to CRT. That is the equation for osmotic pressure. So, four colligative properties are: first, relative lowering of vapor pressure is equals to mole fraction. Second, elevation in boiling point is equals to Kb into m. Third, depression in freezing point is equals to Kf into m. Fourth, osmotic pressure is equals to CRT. All these colligative properties depend upon the quantity of solute that do not undergo association and dissociation. For example, sugar, urea, etc. But in case of NaCl, these formulas will not work because these are dependent on the quantity of solute. If we will add NaCl in water, it will dissociate into Na positive plus Cl negative. Then in this case, we need to add a factor in this formula. That factor is known as Van 't Hoff factor, which we will discuss in next lecture. That's all for today. Have a nice day ahead.